Good afternoon. Today is Friday, September the 11th. Today in geometry, we looked at deductive reasoning, which is a more rigorous type of reasoning than inductive reasoning because you can prove things using deductive reasoning. Now, we have two laws that we learned today, and I will swap over to the share screen and show you what they are. Okay, the first law is what is called the law of detachment. And the law of detachment, if you look at statements, I'll give you an example here, says if a car runs out of gas and the engine won't start. Okay, so now if you look at the statement here, car runs out of gas is the hypothesis, and then the engine won't start is the conclusion. Now, so if I come back in and give you another statement here, which says Ben's car ran out of gas, then what is the logical conclusion? And of course, the logical conclusion is, here, if I go back into here, go back into here. All right, let me do this over so it won't have all these errors in it. Undo. Okay, so I can say Ben's car ran out of gas. Now, my logical conclusion then is that Ben's engine won't start. Okay, now that's the law of detachment. It basically says here, if you write this in statement notation, a car ran out of gas is statement P, and the engine won't start is statement Q. So you say if P implies Q, given P implies Q, and Q is true, if P is true, then the law of detachment says that Q is true. So let me just say then Q is true also. So I'll come down here. Q is true. Now, you cannot say in this case, I could not come here and say that Ben's engine won't start and conclude that Ben's car ran out of gas, because that's not, the law of detachment says you are given the statement P implies Q, and then you come back and say that something matches the hypothesis or the P part, then you can conclude that the conclusion also has to follow, but you can't reverse that process. I can't come in here and say, if Ben's engine won't start, I cannot conclude that Ben's car ran out of gas, because there could be other reasons why the engine won't start. So it has to follow the format. P implies Q and P is true. So the first part of the hypothesis of the given statement has to match the hypothesis of the statement that you're trying to make a conclusion on. So that's the law of detachment. Now, if we come down here, the law of syllogism is often kind of referred to as the transitive law, because the law of syllogism says if P, and I'm going to put the arrow in here in a minute, implies Q and Q implies R, then P implies R. Okay, so I'll put the arrows in. So if P implies Q and Q implies R, then P implies R. Okay, now here's an example of this. So if I come down here and I say, okay, if I make an A on the test, then I get a reward. If I get a reward, then I am happy. Okay? Now, so the law of syllogism here, if you'll notice, if we come into here, the hypothesis of the first statement is if I make an A on the test. And then the conclusion is I get a reward. Now, the hypothesis of the second statement says I get a reward, and then the conclusion of the second statement says I am happy, okay? Now, so what you notice here, the law of syllogism works as long as the conclusion of the first statement is the hypothesis of the second statement. And then I can make a valid conclusion here and say, if I make an A on the test, then I am happy. Okay, so like it says with transitive property, I can go all the way from the hypothesis of the first statement to the conclusion of the second statement, because these middle two comments here, I get a reward and I get a reward because the middle two comments are the same. Okay, so we'll jump back to the other screen here. Now, if you look at your homework assignment, it is asking you to talk about the validity or not of statements. So you use these two laws to be able to allow you to make a conclusion based on what you read. So as always, if If you have questions, send me an email. I look forward to seeing a lot of you back in school on Monday. Thank you.